Hello and welcome to this year's Awesome Day online conference for 2021. My name is Joel Skepper and I'll be your AWS technical trainer for this session, Introduction to the Cloud. As a technical trainer for AWS, I spend most of my time working with those interested in learning about AWS services, from a technical, how does this work perspective, to a hands-on, how do I use this in my operational environment, to how can I architect a solution to meet my business's needs. I teach a variety of courses, such as architecting on AWS and systems operations on AWS. I especially enjoy facilitating a discussion with a customer that gets us thinking in whole new ways. Since the cloud is an ever-changing space, it's always great to hear about new use cases and customer stories. It's a pleasure to walk you through some different foundational services, as well as some new ones in this year's Awesome Day. This year, we'll be walking through some fundamental concepts and key service areas to kickstart your learning journey and help you prepare to start building on AWS. In addition to that, we'll be discussing a few innovation areas you might be interested in knowing more about. This session serves as a great intro to the AWS cloud. So if you're new to AWS or just looking to learn more, you're in the right place. First up on our agenda, we're going to do an introduction to AWS. This is a great place to start for those who have not used AWS before or who are brand new to the cloud. We'll start to get into some of the key service areas: compute, storage, databases, networking, and security. In the second half of our session, we'll shift our focus to some other services that enable innovation on AWS. We will cover some different topics such as Internet of Things, machine learning, blockchain, something called AWS Ground Station for satellite communications. And then we're going to talk about AWS Wavelength, a new service that is underpinned by 5G technology, and how we can use that to expand on applications that are possible today. At the end of our session, we will talk about next steps and what you can do to get hands-on, start building, continue learning, and maybe even get AWS certified. So let's get started with an introduction to the cloud. Firstly, what is the cloud? I like to think of it as simply someone else's computer. But what does that actually mean? Well, you're connected into this Awesome Day session on your computer, maybe a personal laptop, maybe a work laptop, but either way, you're the primary user of that computer. You use it, you keep it secure, you restart it when you have to install updates. Essentially, you're in control of it. On the flip side, if you break it, you're also responsible for that. With the cloud, someone else takes care of that for you. You don't need to manage the physical stuff. You just get to run your favorite applications without having to deal with the underlying infrastructure. So what is AWS Cloud? Essentially, it is a set of programmable resources. The use of IT assets as programmatic resources allows you to quickly tear down and set up infrastructure in a way that just isn't possible with a traditional approach. Secondly, the AWS Cloud gives you access to many higher-level services and features, which lets you design and build applications in a completely new way. You can increase database throughput or maybe compute power, as we'll see later, with really just a few clicks. And then last, one of the biggest benefits of cloud computing is the ability to pay as you go, letting you test and leverage the system without being fully committed. You can stop using these services at any time and change tactics to fit your needs. This is all fine and good, but what are the advantages of using the cloud as compared to, for example, your own on-premises environment? Firstly, we have trading capital expense for variable expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, having a variable expense means that you're only paying for those infrastructure resources when you consume them. And by taking a cloud computing approach that offers the benefit of variable expense, companies can implement innovative solutions while saving on cost. What this means is you can deploy a workload and start getting immediate return on investment without having already committed a large financial outlay and the associated risks that entails. The second advantage that we have is benefiting from massive economies of scale. By using AWS Cloud, you can achieve a lower variable cost than you could get on your own. Because usage from hundreds of thousands of customers is aggregated in the cloud, AWS can achieve higher economies of scale, and that economies of scale translates into a lower pay-as-you-go price because AWS passes this cost savings on to you. Next, you can stop guessing capacity. You no longer have to think about your infrastructure capacity needs are going to be in the next 3, 6, 12 months, or even years from now. When you make a capacity decision before deploying an application, you're often going to end up either sitting on an expensive idle resource that's not being used, or maybe dealing with limited capacity if you decide to set aside less resources up front. Utilizing AWS Cloud, you can provision only the resources you need for any given capacity, and add or remove resources as your requirements change. Which leads us nicely to increasing speed and agility. In a cloud computing environment, new IT resources really just are a click away. It no longer takes weeks for developers to access resources. The resources can be available in minutes. This allows you to respond to unexpected capacity changes. For example, your marketing campaign was more successful than you expected. Or plan accordingly to expected changes. For example, your overnight load versus peak load during the day. This also enables another benefit. Organizations and teams can spin up a proof of concept, and if it's not working out exactly as intended, they can fail fast, so to speak, and stop using those resources right away. As a result, organizations can iterate their development process quicker, at a lower cost, and ultimately go to market sooner. We have this term, undifferentiated heavy lifting, which refers to the actions and tasks that you currently perform that don't add direct value to your business. For example, you might work for a business that has a data center. You have to purchase the equipment, employ administrators to manage that equipment, and ensure it runs optimally over its lifespan. Now think about this. Your competitors likely have similar administrative overhead. They will have data centers with equipment that needs to be maintained. So how do you set yourself apart? Let AWS manage the physical infrastructure. Stop spending money on running and maintaining data centers, and focus on what actually matters to your business. Your customers, your staff, and your product. The last benefit that we have here is the ability to go global in minutes. You can easily deploy your application in multiple regions around the world. As we'll see with our infrastructure, we can achieve global scale with just a few clicks. This means you can provide a lower latency and a better experience for your end customers or end users at a minimal cost. So that brings us to, how does the cloud fit into your landscape? If you think about what you have in your environment, whether it is on premises or located in a data center, you'll have servers, storage, networking, and databases. Ultimately, you have applications and workloads running on your physical infrastructure. The cloud doesn't operate all that differently. You're still going to have those resources and have the ability to access them, but you're going to do it in a much more flexible manner over the internet. We'll talk about some of the ways we can do that as we get into networking a little bit later. If you think about what you have on premises, AWS has services that can help you meet the need. Thinking about security, you might be already familiar with firewalls, access control lists, and maybe even have network or security administrators within your team or your company. AWS has services that enable you to deploy similar security constructs. We have security groups and network access control lists, which we'll talk about in the networking module coming up. We've also got a service called Identity and Access Management, or AWS IAM, which helps you provide authentication and authorization to users of the different resources we're going to be talking about. So you have the ability to manage that through one service. From a networking perspective, you might be familiar with physical devices such as routers or switches, or basic networking concepts such as IP addressing, traffic distribution, and flow. We have services such as the Elastic Load Balancer, which gives you the ability to distribute traffic amongst multiple different targets or instances, as we'll talk about coming up. And then we've got the Virtual Private Cloud, or VPC, which is your private network in the cloud, allowing you to control how your resources are connected to each other. When it comes to servers, you might be familiar with managing, deploying, patching, or operating servers on premises, or maybe in a co-location. A key AWS service to meet this need is Elastic Compute Cloud, or EC2. We'll learn more about this in the next module, but essentially it allows you to deploy a virtual server that you can run your workloads or applications on. AWS offers a number of different storage options depending on your requirements, whether that's network-attached storage and persistent disk, maybe scratch spaces or caches, file systems to be shared between different hosts, and even simple object storage for a wide variety of applications. AWS has more than 15 purpose-built databases. Amazon Elastic Block Store, or EBS, offers easy-to-use high-performance block storage at any scale. Amazon Elastic File System, or EFS, provides a scalable cloud-native NFS file system. Amazon Simple Storage Service, or S3, provides object storage built to store and retrieve any amount of data from anywhere on the web, which we'll talk about in the next module. So hopefully this helps you to apply your current knowledge to different AWS services that we'll be talking about. In the coming modules, we'll go into a little bit more deeper knowledge about AWS services. Let's have a look at how some of these services tie together with a simple example. Let's say you have a web application which sits on a server that is accessed via the internet. The web application also needs access to some external data sources. As you can see from this architecture diagram, we have different services connected together to create an environment. In the middle, we have EC2, which, being a virtual server, hosts the actual web application. The application is stored onto an EBS volume, which provides block storage to the EC2 instance. The EC2 instance is deployed into a VPC, which provides networking access. As far as data sources go, the EC2 instance can access data in S3, which is object storage, or DynamoDB, which is a non-relational database. External users can access this web application via Route 53, which provides DNS resolution. We will speak more about these services in the modules upcoming. Keep in mind this is a simple example, but you can see how, by connecting different services together, you can come up with a huge variety of different solutions, depending on what your requirements are. One question you might have is, well, how does this all work? How can we build a solution in AWS that connects to my on-premises environment? As I spoke about earlier, AWS Cloud is a set of programmable resources. There are ways to connect into AWS that allow direct connection between your environment and your AWS environment, enabling secure communications that bypass the internet. AWS achieves this by deploying robust physical resources around the globe. These resources are housed in data centers that are physically connected by AWS-owned network hardware. You then access the services you need via the Services Application Programming Interface, or API, which allows different methods of interaction. More on this later. Something important to consider is that we have different deployment models and ideas for different cloud maturity levels. What if you work for a corporate enterprise that was set up prior to the internet? It is likely you are going to have a large physical infrastructure deployment that you've used and had for years. This is your on-premises environment. You're not going to just want to turn it off on Friday night, migrate everything into the cloud on Monday, just start operating in the cloud. Alternatively, what if you work for a startup, a brand new company with this great new revolutionizing idea? Chances are you're not going to have the financial capital, nor time, or even desire to invest in an on-premises environment. So you might be thinking of a cloud-native design. AWS cloud deployment models cover all variations across that spectrum. On-premises environments can be slowly migrated such that you operate in a hybrid model, where you have workloads and data in both your on-premises environment and your cloud environment. Whilst new or greenfields applications can be designed with cloud deployment in mind, making use of high-level services. Two terms come to mind here. Cloud native, which refers to applications that have been designed and deployed only in the cloud. Think newer applications in your business, and all in, where you have migrated all workloads from your on-premises environment and are now ready to shut it down. Ultimately, it doesn't matter where you are in your journey. Once you start moving data into AWS Cloud, you can start making use of the services and advantages that AWS Cloud provides. Speaking of moving your data into the cloud, where does the cloud actually sit? Thankfully, the cloud is not some esoteric concept. Rather, it is a concrete service that has physical infrastructure deployed globally. So if we're going to think about where their cloud actually is, we need to learn about the AWS global infrastructure. AWS global infrastructure is primarily made up of regions, which can be thought of as geographical locations. Need to deploy a workload in Australia? No worries. Deploy into the Sydney region. How about running a workload in Europe? Great, you've got plenty to choose from. London, as an example. There are multiple regions deployed globally. An updated list can be found on the AWS infrastructure page, infrastructure.aws. Next, we have availability zones. Availability zones, or AZs, are a subsection of a region. An availability zone is a fault-isolated domain, which allows you to create high availability within your applications. Availability zones have their own power supply, network connections, and are designed to be on different floodplains and accessed via different infrastructure. This means that a single availability zone failure should not impact other availability zones. This gives fault tolerance to the region as a whole. A region is typically designed with 2 or more availability zones to ensure high availability and fault tolerance. Each availability zone is made up of 1 or more data centers. The data center is a highly secure facility housing all of the physical infrastructure that makes up the cloud, such as compute servers, physical disk for storage and networking, amongst other devices. For the majority of workloads, you will interact only with the region or the availability zone. AWS infrastructure regions meet the highest level of security, compliance, and data protection, and there's currently 25 regions worldwide. Another important infrastructure element is the edge infrastructure. Displayed on the screen are the edge locations distributed globally. We use these to bring content closer to your customers to improve performance. They can also be used to increase security and reduce cost. This can be achieved by redirecting traffic to the edge locations and caching content. A key service that uses edge locations is Amazon CloudFront, a content delivery network, or CDN. We have additional services that operate at the edge, including AWS Outposts, Local Zones, and AWS Wavelength. Let's have a look at these. Starting with AWS Outposts. Outposts is a fully managed service that extends AWS infrastructure, AWS services, APIs, and tools to virtually any data center, co-location space, or on-premises facility, providing a consistent hybrid experience. Local Zones is a new type of AWS infrastructure deployment that places AWS compute, storage, databases, and other select services closer to large cities, industries, or IT centers where there is currently no AWS region. And finally, we're actually going to talk about this one a little bit later, is AWS Wavelength, a new service that works with 5G technology. So how do we actually interact with these services? I previously mentioned one of the ways, AWS Management Console, which is the easiest way to get started if you haven't worked with AWS before. It has an easy to use graphical interface. All you need is an AWS account, which is free to create by the way, and log in and there you are. You can access the various services that we're going to talk about today. If you're in an operations or systems administration role, you may want to use the AWS Command Line Interface, or CLI. The CLI is a unified tool for managing, controlling, and automating many AWS services through discrete commands. The CLI provides a suite of utilities that can be launched from a command program in Linux, Mac, or Windows. And finally, our third option here is via the Software Development Kits, or SDKs, which let you access AWS services through your code or applications using a number of familiar programming languages, like Python, for instance. One thing each of these methods has in common is that no matter which way you choose to access AWS services, you're still interacting with the AWS APIs. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of this session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Thank you for attending this session.